try this one, or at least set this one up. This one we're not going to finish. We're going to set it up and leave it for you to finish as practice. But we're going to integrate tangent of x dx. And this is not one of our basic forms. So this is not one of our elementary form integrals. It's not one we can just know. So we have to kind of work through it. And since it's not one we just immediately know, there's really no algebra we can do here to simplify this down any further. Substitution rule is probably applicable. And so the question is, how do you choose u? There's only one piece of our function here, just tangent of x. Well, so the question is, how do you choose u? If you're going to do a substitution rule, well, I mean, there is tangent x, so we could let u equal tangent x. See what happens. When we calculate the derivative of tangent x, we get secant squared x dx. And now secant squared doesn't show up anywhere here. So most likely, this is not the correct approach. It's worth a try. So maybe if we got really creative, we could make this work. But if we're just kind of going through ideas, we want to kind of look for something that is hopefully obviously going to work. And when we get this differential, the secant squared doesn't show up any here, probably isn't going to work. So we're gonna cancel that out. Probably is not going to work. Maybe if we're creative, we could get it to. I don't know. We want to try something else. Well, when we first looked at how to differentiate tan x, we know tangent is related to sine and cosine. So we could rewrite this as sine of x over cosine of x. And this is a common strategy that you're going to explore further in Calc 2 is when we're integrating trig functions, a lot of times we want to try to relate them back to sine and cosine. All right, so sine and cosine we have here. This is fine. Sometimes it's helpful, though, once we have a fraction, to really break that fraction apart. Look at the different pieces. So I'm going to have 1 over cosine x times sine of x, just to kind of break that fraction apart. And so now if we look at this kind of new format for our function, we have some choices on what u could possibly be. So let's go through them. We could let u equal cosine x. We could let u equal the 1 over cosine x, or we could let u equal the sine x. So if you're not sure where to go, just kind of look at all the different pieces of your function and just think what u could be. What are all the pieces that you see? So I see a cosine x, maybe u is that. I see 1 over cosine x, well, maybe u is that. When I see a sine x. So let's actually try out the differential for each of these and see which one of them gives us the closest match. So if I were going to calculate the differential here, what's the derivative of cosine x? Well, that's negative sine x dx. What's the differential here? If I was going to differentiate 1 over cosine x, well, that's negative 1 over, well, it actually ends up being positive once we do chain rule. So you'd have to use chain rule here. 1 over cosine squared x times sine x dx. And I'm getting short on space, so we'll throw the u equal to sine x down here. So when I calculate derivative of sine, my other option, I get cosine x dx. All right, so there are the kind of the three choices. And what we want to do is we want to look at, well, if we want to look at this differential and see if it matches with what we have. So if I'm letting u equal, let's start with this u equal to sine x. So that means I'm taking care of this sine x. And then I just look at what I have left over. So I have a 1 over cosine x dx, and that doesn't really match up too well with what I calculated. I calculated a cosine x dx, and that doesn't match up too well. So it's really not a good match. With the 1 over cosine x that we would have left. Maybe there's something we could do, but right now it's not a good match. So I would probably move on and try something else. So you can normally tell if a substitution is going to work by what happens when you calculate the differential. So cosine x doesn't really match up with this 1 over cosine x. And then same thing, if we go to this substitution, if we're going to try 1 over cosine x, again, that means that this fraction is going to be taken care of. And then we're just matching these leftover terms. So my leftover term in the integral then is sine x dx. And if I compare that, I have this 1 over cosine squared x times sine x dx. So there's more going on here. Again, it's not a particularly good match. Maybe there's something we could do to make it work, but as it stands, there's a lot more going on here versus what we have in our integral. So we're just kind of comparing what we calculate with what we have left. So I would probably say, let's cross that one out. And we're just going through our options. So this is, again, if you see the substitution right away, you might not have to do this. What we're doing is we're just kind of, if you're stuck on a problem, trying to give some strategies and techniques that might help you on how to choose u. So just list out all the options and then go through and see if what you calculate for the differential really matches the leftover pieces. So let's go here. U equal to cosine x. So that's going to mean this cosine x here is accounted for. So that's not too bad. And then sine x dx and sine x dx. That's a nice match. So you know you're probably on the right track if the leftover terms in your integral match up pretty nicely with the what you calculated for your differential. Now there is this negative here, but that's just an extra constant. It's just a -1. And so we know we can move that constant to the other side. We could solve this for sine x dx and move the negative over to the other side. So as practice, finish trying this problem with this substitution where you let u equal to cosine x and the differential here is negative sine x dx. And what you should end up with, what do you end up with? You're going to end up with negative natural log of absolute value cosine x plus c. That's the answer. All right. So good practice. And this one's a good setup for, there's going to be a whole lesson or two in Calc 2 devoted to integrating trig functions using a strategy similar to this, where you rewrite it in terms of sine and cosine. All right, so what do we got? One more example coming up. We'll see you there.